Hi, here is Picture Generation 4 research competition in 2025. My name is Xingguang Zhou, an engineering doctoral candidate at Nuclear Thermohydraulics Laboratory in Xi'an Jiaotong University. I would like to share my work entitled High Fidelity Neutronics of Double Heterogeneity in TRISO and Helical-Cruciform field. With the development of Generation 4 advanced reactors, TRISO and Helical-Cruciform field are adopted to ensure safety and improve heat transfer ability. However, new heterogeneities are introduced, and the Monte Carlo simulation is required for a benchmark evaluation, which is necessary for reactivity investigation. Here shows the TRISO particle and the lateral section of HCF, different from the uranium dioxide distributed uniformly in cylindrical field. Double heterogeneity in hexagonal lattice is described here. The first heterogeneity is introduced by the TRISO particles, which need to be explicitly modeled, and the second heterogeneity is introduced by the HCF. We propose a HCF and a cylindrical field with the same field capacity, say the Wegener size equivalent in a hexagonal lattice with the reflected boundary condition. It is obvious that the neutrons in HCF lattice are expected to be more easily absorbed by the Doppler resonance effect. Since the HCF is a 3D twisted shape in reality, and it is difficult to be directly modeled in the Monte Carlo method. Here we propose the geometric approximation method. We divide the 3D twisted HCF into several 2D slices, and each slice will rotate it with a certain angle based on the previous one. This operation is carried out by a Python script developed in this study, and we have open sourced this script at this repository. Now we explicitly model the TRISO particles, and we will make the geometrical approximation with different section numbers of each pitch. From the result, it can be found that when the section number of each pitch larger than 80, the engine value fluncates within the 40 PCM, which shows the section number independence. Besides, we also gather the relative scalar flux. Finally, in this study, an approximation method is proposed for high fidelity neutronics of double heterogeneity in TRISO and Helical-Cruciform field. Besides, we hope the results obtained in this study could be used as a benchmark reference for Generation 4 reactors with novel field design. Thank you.